Class 1500 swing check valve can be listed against several respected standards and still leave one critical question unresolved. Which standard governs each feature of the valve being purchased? That question matters because a swing check valve must satisfy two functions at once. It is a pressure-retaining component, and it is also a moving closure device intended to control reverse flow. A standards list alone does not prove that the body design, material, dimensions, end connections, pressure-temperature basis, inspection, and testing all apply to the same configuration. A practical review begins by identifying the exact valve, size, pressure class, pressure-retaining material, trim, and end connection. The buyer then assigns each reference a defined role. One reference may support design and pressure-temperature suitability. Another may control face-to-face dimensions or flange interfaces. A further reference may address welding end compatibility, inspection, or testing. These roles should not be treated as interchangeable. The pressure class is only the starting point. Temperature and material determine how that class is applied. The supplier should identify the pressure-retaining material and provide a rating statement for the specific configuration. This creates an auditable link between the selected class, the actual valve construction, and the project design conditions. A nominal class should never be treated as a temperature-independent promise. Dimensional and connection references control whether the valve can be installed without rework. Face-to-face dimensions affect piping spool design. Flange information affects the mating interface, including nominal size, class, facing, bolt pattern, gasket concept, and connected flange standard. For butt weld ends, the review should also cover end preparation, pipe material, weld procedure, inspection, and any post-weld requirements stated by the project. Material names are not material evidence. Configurations may identify materials such as WCB, CF8, WC6, or LCB, but the procurement package must state which individual parts require certificates and how those certificates will be tied to the valve. Depending on project requirements, the evidence may also include positive material identification, heat treatment records, hardness checks, or third-party review. Testing references become useful only when their application is explicit. The inspection and test plan should identify shell tests, seat tests, dimensional checks, visual examination, document review, witness responsibilities, and the required acceptance format. Test reports must be traceable to the approved configuration and the applicable acceptance stage. API 6D, ASME B16.34, and BS 1868 may appear together in a technical data sheet, but their presence does not by itself establish a complete compliance case. When API 6D is listed, the supplier should explain how it applies to the ordered valve and what inspection or documentation will be supplied. When ASME B16.34 is listed, the review should connect the actual material and design conditions to the selected class. When BS 1868 is listed for a cast steel swing check valve, the project should clarify whether it is the governing design reference, an additional project reference, or part of a legacy specification. The strongest control is a single configuration identifier carried through the datasheet, drawing, material list, inspection plan, and test reports. The same identifier should connect the purchase line to the approved document revision and final handover file. For procurement teams, the required action is straightforward. Map every claim standard to a valve feature, a control document, and a responsible review. Resolve conflicts through recorded clarification or an approved exception before shipment. This turns a broad standards list into a controlled evidence chain, allowing suppliers to be compared on the completeness of their documentation rather than on the number of standard names they display.